In this video, let's have exercises on set operations with Venn diagram. Okay, let's have number 1. A union B. Okay, what are the elements of A union B based on the given Venn diagram? Now look at the Venn diagram here. So the regions that belongs to A union B are S sub 1, S sub 2, S sub 3, S sub 4, S sub 5, and S sub 6. Because these regions are in A or B. So therefore, the elements that belongs to A union B are 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, what about B union C? What are the elements of B union C? Okay, the elements of B union C are the elements in the region S sub 2, S sub 3, S sub 4, S sub 5, S sub 6, and S sub 7. So therefore, we have 4, 5, 9, 10, 6, 7, 8, 11, and 12. What about number 3? A union C. What are the elements of A union C? So these elements are in the regions S sub 1, S sub 2, S sub 4, S sub 5, S sub 6, and S sub 7. So the elements therefore of A union C are 2, 3, 4, 5, 9, 8, 10, 11, and 12. Okay, so let's have another problem. This time, the operation is intersection. Okay, let's have A intersection B. So the regions in the Venn diagram where there is an intersection of set A and set B are S sub 2 and S sub 5. So therefore, the elements in the Venn diagram that belongs to the region S sub 2 and S sub 5 are the elements of the intersection of set A and set B. So we have 4, 5, and 9. What about A intersection C? So what are the regions that belongs to the intersection of set A and set C? We have S sub 5 and S sub 4. So therefore, the elements here, based on the Venn diagram, the elements of the intersection of A and C are 8 and 9. What about B intersection C? What are the regions that belongs to the intersection of set B and set C? So we have S sub 5 and S sub 6. So therefore, the elements of the intersection of set B and set C are 9 and 10. Let's have another operation. This time, difference. Okay, so let's have A minus B. Okay, so what are the regions in the Venn diagram that belongs to A only? No, that belongs to A but not B. A but not B. So we have S sub 1 and S sub 4. Okay, so therefore the elements of A minus B are 2 and 3 from S sub 1 and 8 from S sub 4. What about B minus A? So these are elements that are in B but not in A. So what are these regions in the Venn diagram? B but not A. So we have S sub 3 and S sub 6. So the elements that belongs to this region, S sub 3 and S sub 6 are 6, 7, and 10. What about A minus C? What are these regions? S sub 1 and S sub 2. So what are the elements that belongs to S sub 1 and S sub 2 here? In the given binary, we have 2, 3, 4, and 5. What about C minus B? Okay, C but not B. What are the regions that belongs to C but not in B? So these are S sub 4 and S sub 7. So therefore the elements are 8, 11, and 12. Okay, what about C minus A? Okay, these are the elements, these are the regions in C but not in A. So we have S sub 6 and S sub 7. So therefore the elements are, we have 10, 11, and 12. Okay, so this time let's go to the next operation, the complement. Okay, step number 1. Okay, the complement. We have, say, A complement. What are the regions that belongs to A complement? So the regions in the Venn diagram that are not regions of set A, we have S sub 3, S sub 6, S sub 7, and S sub 8. So all the elements that belonging to these regions are elements of A complement. So we have, from S sub 3 we have 6, 7. From S sub 6 we have 10. From S sub 7 we have 11 and 12. And from S sub 8 we have 0, 1, and 13. Okay, what about B complement? Okay, you can pause the video and try. What are the elements of B complement? Okay, so everything, all the elements that are not in set B are the elements of B complement. So we have here from S sub 1, 2, and 3. From S sub 4 we have 8. From S sub 7 we have 11 and 12. And from S sub 8 we have 0, 1, and 13. Okay, 0, 1, and 13. Okay, what about number 3, C complement, the complement of set A. So elements that are not in set C, these are 0, 1, 2, 3, 4, 5, 6, 7, and 13. Okay, this time let's try a little bit complicated problem involving already more than one operation. Let's try number 1. What about if the given operation is A union B union C? So what are the regions in the Venn diagram that belongs to the union of the three sets? Okay, so all the regions except S sub 8. So S sub 1, S sub 2, S sub 3, S sub 4, 5, S sub 6, and S sub 7. So therefore, the elements of A union B union C are 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, except 0, 1, and 13. What about number 2? What if the problem is A intersection B intersection C? What are the elements of the intersection of the three sets? So observe that the three circles overlap in at S sub 5. So the region S sub 5 is the common region to the three sets. So therefore, the element only of S sub 5 here in the given Venn diagram is 9. So the result is 9. Okay, so what about number 3? What if the problem goes this way? A intersection B union C. Okay, observe that there is already a parenthesis here, a grouping symbol. Now, according to the rule, we must perform first the operation inside the grouping symbol. So this will be our step 1. Okay, so we perform first intersection, and our step 2 is we take now the union as the main operation and getting our final answer. Okay, what are the elements therefore? Okay, in step 1, we determine the elements of A intersection B. What are the elements of A intersection B? We have 4, 5, and 9. 4, 5, and 9. Union. And what are the elements of set C? Unions. Ah, okay. Let's erase first. Okay. Okay, so we can just directly go immediately here in step 2 and write the final elements here. So let's take step 2. Okay, so we're going to uh, take the union of the elements obtained in step 1, which are 4, 5, and 9, with the elements of set C, which are 8, 9, 10, 11, and 12. So first, let's list the elements of set of A intersection B, which are 4, 5, and 9. And then we are going to list the elements of set C. Okay, we have here 8, and then we're not going to list 9 anymore because we have listed it already. Then 10, then we have here 11 and 12. So that is the answer in number 3. Okay, so let's have another more complicated problem on set operation. Okay, let's try this. A complement, a union, C complement. Okay, what are the steps here? We have 3 steps. First step, we perform the operation complement of set A. Step 2, we take the complement of set C. And step 3, our final operation or our main operation. So step 1, what are the elements of A complement? So we have 0, 1, 11, 12, 10, 6, 7, and 13. What about the elements of C complement? Okay, we have 0, 1, 2, 3, 4, 5, 6, 7, and 13. And for our final operation, let's take the union of these elements to determine our answer. First, we list all the elements of A complement: 0, 1, 11, 12, 10, 6, 7, and 13. And let's add the elements of C complement which are not in A complement. 0, 1, 0 and 1 already listed, so let's add 2, next 3, then 4, then 5, what about 6? We have listed already 6, 6, 7, 13. Okay, these are all the elements of the given operation. Okay, let's have another problem. Let's try this. A complement union C intersection the complement of B union A. Okay, it's really quite complicated problem. Okay, what are the steps that we are going to have here? How many steps? Okay, so according to the rule, we are going to perform the operation inside the grouping symbol first, the parentheses. So, and the main operation here is the intersection. Intersection. Okay, and then, so our first step is we're going to perform a complement. Second step, take the union with set C. And the third step is we are going to take the operation B union A. Step 4, we're going to take the complement of this operation B union A. And step 5, which is our final operation to determine the final answer, or the final elements of this given problem here in number 1. Okay, so let's try. First, let's take A complement. What are the elements? What are the elements of A complement? We have, so all elements that are not in A: 0, 1, 11, 12, 10, 6, 7, and 13. Okay, union. Okay, union with set C. Okay, so we have here step 2, A complement union C. Okay, okay, we take the union of set C with A complement. So let's list all the elements of A complement first. 0, 1, 11, 12, 10, 6, 7, 13. And let's list the elements of set C which are not in A complement. We have here 11 is already in A complement. What about 8? Okay, let's list 8, 9, 10. 10 is listed already here. 11 and 12 is listed already. So these are the final elements for A complement union C for step 1 and step 2. And then let's have step 3 here. So our step 3 is B union A. What are the elements of B union A? Okay, B union A, the elements are 2, 3, 4, 5, 8, 9, 6, 7, and 10. Okay, and then step 4, we're going to take the complement now of B union A. So all elements in the universal set which are not elements of B union A. So what are these? So look at the Venn diagram. Okay, so we cannot see 0 in B union A, so 0 is an element. What about 1? Yes, we have 1. What about, okay, so here 11, then 12, and 13. Okay, so we are done with step 4. Okay, so for now, let's have the final step, or we're going to perform now our main operation intersection. So here, so the result from step 1 and step 2, this one, this is the result of step 1 and step 2. These elements, A complement union C, this one. And the result of step 4 is this one. These elements, B, the complement of B union A. So we are going to take the intersection of these elements obtained from step 1 and step 2 and the elements obtained from step 3 and step 4. Okay? So what are the common elements? Okay, the common elements here are, we have 0, 1, 11. What else? We have 12 also. What about 13? Okay, 13. Okay, there are no other common elements. So therefore, the result of these operations in number 1 in this given problem are the elements 0, 1, 11, 12, and 13. Okay, so let's have one more last problem. Another complicated problem. Okay, so for suppose the problem goes this way. A complement intersection B complement union A complement intersection B intersection C complement. It's very complicated, but let's try. Okay, so what are the steps that we are going to have here? How many steps are we going to have? So let's we have here our step 1 is we're going to take the complement of set A. Step 2, take the complement of set B. Step 3, take the intersection, because we're going to perform first the operation inside a parenthesis, inside a grouping symbol parenthesis. Then step 4, take the complement. Then this is our main operation, so this will be our last step. So step 5, we'll take the complement of set A. Then step 4, take the intersection with set C. And step 5, we take the complement of the intersection of set A and set C. And sorry, this is step 6, step 5, step 6, step 7, and step 8, we take the union. Okay, so many steps to undergo, but let's be patient here so that we can get the correct answer. So what are the elements of A complement? Okay, A complement. The elements are, we have 0, 1, 11, 12, 10, 6, 7, and 13. And what are the elements of our B complement? Okay, the elements of B complement are 0, 1, 2, 3, 8, 11, 12, and 13. Okay, and let's have step 3. This is our step 1, step 2, and step 2. And step 3, we determine the intersection A complement and B complement. Okay, so let's use another color so that you can easily see the result. Let's look for the common elements of A complement and B complement. We have 0, 1, 11, What else? 12 and 13. So the elements of A complement intersection B complement are 0, 1, 11, 12, and 13. Okay. Okay, so now let's have step 4. Our step 4 is already to take the complement of the intersection of A complement and B complement. Okay, so what are the elements which are not in this set 0, 1, 11, 12, 13 and are found in the universal set? So we have here 2, 3, uh, 8, 5, 9, 4. We have 6, 7, 7. What about 10? We have 10. What else? 0, 1, 11, 12, 13. 0, 1, 11, 12, 13. Okay, so let's check. 2, 3, 8, 5, 9, 4, 6, and 7, and 10. So, okay, these are all complete already. Okay, now let's have step 5 here. Let's have step 5 here. Let's use another color. Step 5. So A complement. So what are the elements of A complement? Okay, we have obtained it already here. We have 0, 1, 11, 12, 10, 6, 7, and 13. Then we need to get the intersection with set C as our step 6. Okay, A complement intersection C. Let's have step 6. So what are the common elements of the A complement and set C? Okay, so let's look at the elements of set C. What are the elements of set C that are in A complement? 8, no 8. We have 10. 10 is an element of set C and at the same time element of A complement. Then what else? I guess it's only 10. We have 11. 11 and 12. 10, 11, 12. We have 10, 11, 12. Okay. 10, 11, and 12. Okay, now this time let's have step 7. Okay, this time we are going to take the complement of step 6. The complement of the intersection of A complement and set C. So, okay. So what are these elements? Okay, these are all the elements of the universal set except 10, 11, and 12. So we have here 0, 1, 2, 3, 4, 5, 8, 9, 6, 7, and 13. Okay. Okay, so now let's come to the final operation so that we can now get the final answer for this given operation, the union. Okay, so I will use another color here. It's fine, blue. Okay, so observe that these elements are the result of our step 4, or the final step in performing the operation at the left side of the universe of the union operation. So this one, these elements, and then we're going to take the its union with these elements here. Okay, so let's write our final answer. So the elements therefore are 2, 3, 8, 5, 9, 4, 6, 7, 10. Then let's continue listing the elements of from step 7, which are not listed from the elements of step 4. So we have 0, 1, so we'll not write 2, 3, we will not write 4, we will not 5, we will not write 8, we will not write 9, we will not write 6, we will not write 7, but we are going to write 13 here. Okay, this is now the final answer for this given problem. That's it.